Hey guys, today we're going to talk about sex-linked genes or sex-linked traits, which are traits that are only found on the X and the Y chromosomes. So let me show you what we're working with here. We got 23 pairs of chromosomes in all of our cells. You can see that they are numbered here up to 22, and then the last pair is we call the sex chromosomes. And so you either have an X and an X chromosome or an X and a Y chromosome, and that determines biological male or female. So if you have XX, that is female, and if you have XY, you are male. So this last pair here, you'll see, is not really like all the other pairs, which are all the same size and shape. So with this final pair, the X chromosomes actually are quite a bit bigger than the Y chromosome. Okay, so this is going to mean that the X chromosome has more genes on it than the Y does, and also they're not all the same genes. So on all of the other chromosomes here, we have, like, let's say, a gene for hair color. It's on both of them. It might be brown or blonde, but it's the same gene in the same location. Here, some of the genes that are found on this X chromosome are not found on this Y one, simply because it doesn't have the same number of genes. Okay, so here's another photo of this. This is an electron micrograph of this, and you'll see that we got a big chicken tender here, the X chromosome, and then we got a little chicken nugget over here, which is the Y chromosome. Okay, cool. So we got X and Y. Let's write down some stuff. Genes that are carried on the X and Y chromosomes. And I would like you to just draw a little X and Y chromosome too. So you can be like, this is your X, and then just know the little nugget is the Y. Okay. All right, these chromosomes contain genes that determine if you're male or female, among other genes. All right. So let's talk specifically about something called X-linked genes or Y-linked genes. So X-linked genes are genes that are only found on the X chromosome. So like I was saying, you can have ones that are found here. Here's maybe a section of chromosome that, here's your DNA. No, never mind. Here's your DNA that is not found on this one, okay? Not found there. So X-linked genes are genes that are only found on the X chromosome. And that means, I bet you can guess what Y-linked genes are. They are only found on the Y chromosome. So there's some interesting things here that can happen. For example, I think kind of a fun one is there's a certain type of male pattern baldness that is a gene linked to a gene that's only found on the Y chromosome. So it's only passed on from fathers to sons and is not inherited by ladies. So that's the kind of thing we can see here with some of these different things. The Y-linked genes, that's pretty simple, right? It has to be passed on from father to son because fathers have X, Y, and so here's the mom and here's the dad, and mom is going to pass down an X chromosome no matter what. Dad, if you have a son, is always going to pass down a Y. So anything that the dad has is only going to be passed on to sons and not to daughters. Because if this couple had a daughter, it would be like mom passes on the X and dad passes on an X. And so anything that's found on the Y chromosome doesn't go to the daughter. So the Y-linked genes, like I said, are kind of easy, pretty simple to deal with. The X-linked genes are a little bit more complicated, and that's what we're going to talk about now. Okay, I already kind of talked about this. The X chromosome carries more genes than the Y chromosome, and it's bigger because it has more genes. Okay, the chromosomes are made of DNA, so it obviously has more genes on it. All right, so the first thing I want to talk about here is a disease called hemophilia. And hemophilia is a disease where you can't clot your blood like you normally would. Okay, so normally, say if you get injured right here, and your blood vessel ruptures, okay, so you just get a cut or whatever, your red blood cells are going to start pouring out of the cut. And so what happens is you have something, you probably heard of platelets, and then you also have this other protein called fibrin, and it basically seals up the side of the wound here. Well, with hemophilia, you don't clot your blood as effectively, and so you can bleed for longer periods of time than you should and lose a lot more blood. And this is it there's a spectrum of how bad this can be for different people. Some people have it really bad, and some people don't have it as bad. But it's basically just uncontrolled bleeding. Okay, so this turns out to be an X-linked recessive trait. Okay, so when I say recessive, what I mean is that just like before we did codominance, we had big R's and little r's, and this is dominant and this is recessive. So let's say that big R is normal blood clotting, and little r is hemophilia, right? So that's what it means to have a recessive disease. We would need to have two little r's in order to have, I don't know what happened there. You would need to have two little r's in order to have hemophilia, okay? If you had a big R, little r, then you would have one of these, which means that you would clot your blood normally. So it is also an X-linked trait. So that this means it is only found on the X, okay? So what does this mean? Well, for our genotype. So let's say for a female, here's how we're going to write stuff, okay? Female is XX, okay? So that means for a female who has hemophilia, so female with hemophilia, is going to be X little r, X little r. That's going to be our notation. So a male with hemophilia is going to be XY, right? That's their genotype. And you're going to do X little r, X little r, Y, nothing here, okay? We're not going to write anything there. I'm just going to erase that, actually. That looks ugly. So because this is an X-linked gene, so the Y chromosome does not have the gene for hemophilia, okay? So what does this mean for like males versus females getting the disease, okay? So, you know, females have two X's and males have one X, and that's where the gene is found. So we're going to dive into this, what it means, okay? So we just kind of saw this, and I just want to show you the chromosomes version of this, because I just want to remind you why we're writing X and Y. When I write X, R, Y, I mean that this gene, the little r, is on this chromosome, okay? But it's not found on this chromosome anywhere. Okay, so both of these, this would be a male, like I just wrote in the last slide, with hemophilia. This would be a female with hemophilia. They both have hemophilia. So the question is, a son or daughter more likely to inherit hemophilia? Let's look at a couple more slides. So, okay, let's say the mom is a carrier, or a mom is heterozygous. Okay, so carrier and heterozygous are the same thing. So carrier means she carries the gene for it, but she does not have the disease because she has a big R, which is dominant, which was normal, right? So the big R is normal, little r means hemophilia. The dad here is also normal because he has a big R. Nothing goes on the Y chromosome. So let's say that this mom gives, oh, you know what? Sorry, I don't need to do that. Let's say the mom, hold on. Let's say that the mom gives a little r, and the dad also gives a big R, and they have a daughter. Okay, so if they're having a daughter, what's happening here is that it's kind of like this. I will just do this. So let's say, okay, if the mom gives a little r, and let's see, we can see this happening in real time. We're like, oh no, is this daughter going to have hemophilia? But then it's like, no, because dad has a big R, and so the daughter basically has two chances to get a little r, and so that is going to mean that she is going to be less likely to have hemophilia, because let me show you what it's going to look like for the son. Okay. So I do want you to write this, okay? So you can do it like this. If you go X big R, X little r, and then X big R, Y. And so if they have a daughter, let's say mom gives this one, and dad gives this one, okay? And so this daughter does not have hemophilia. This daughter has a normal blood clotting, okay? However, if they have a son, so let's talk about if they have a son, okay? So let's say the mom gives the same one and dad gives a Y. Well, in this case, look what happened. We have a son with hemophilia. So the son only has one chance to either have it or not have it. The daughter has two chances to either have it or not have it. So we can write this too. So let's say same situation. So example number 2. So even with the same parents right here, the son is more likely to get it. Okay. And we'll do some math here in a second too. So say the mom gives this again, X little r, but they're having a son and Y. So basically this kid right here had a 50% chance of getting the disease. Okay, the son had a 50% chance. If we go back to the daughter, let me get rid of all this ink on the slide and then go back a little bit. So the daughter, if we go back here, okay, so we're saying this one is going to get passed on, and then this one gets passed on. Well, this kid, so the chances of this being a big R or a little r, that was 1/2, right? And the chances of this being a big R, a little r, let's say, would also be 1/2. The dad could have it or not have it. And so we would have 1/2 times 1/2 is 1/4. So that is less likely than what we saw in the next slide, where their chances of having it or not having it. So right here, the chances of having or not having it is 1/2. And so that is 50%. So boys are more likely to have hemophilia than girls. And you probably noticed that in the royal family video. Okay. All right. So I just want to do a real quick problem just to make sure we're all on the same page here. So it says, this is a new thing. We're moving on from hemophilia for a second. Example problem. Determine the sex and eye color of the following fruit flies. This is actually true. You have red or white flies. So is this a male or female? And does it have red or white eyes? Fill that out. I want to see this at the bottom of your notes. And then again, is this a male or female? And does it have red or white eyes? Okay. I'm going to be looking for that on your notes. Make sure we're all together here. Okay. Thanks. Let me know if you have any questions. Bye.